Buonasera, buonasera.
Good evening, ladies and gentlemen, and welcome to this new event, Trento Scienza Grandi Eventi, a meeting organized by Muse in collaboration with the province of Trento, the University of Trento, Fondazione Bruno Kessler, and Fondazione Edmund Mach. My name is Elisabetta Curzel. I'm a journalist, and it's a pleasure to be here together with you and together with the speakers that I'm going to introduce in a while. Well, the topic of this evening is a huge scenario. We will speak about the universe, which is outside and inside us. So this evening's guests represent disciplines which are not normally connected. We are speaking about astrophysics and philosophy. And the persons here close to me will tell us by means of their experiences and by telling us about their professional life, they will tell us that, in fact, there is a connection between these two things. Now, some management information. This conference can be also seen directly on the FB channel of the museum. And I would like to say hello to all those who are connected with us online. And the registration of the conference will be present on the YouTube channel of the museum. And then one point for those who do not speak English. If you want, there is a headset for translation carried out by Anna De Poli and Claudia Marsilli. Now, a couple of words about the meeting. We will have first the presentation of Sibylle Anderl, and then Paolo Costa will make his presentation, and then it will be your turn to make questions if you want.
Entriamo allora nel vivo.
Now, let's go to the heart of our meeting. I'll put on glasses because I don't want to make mistakes. So on my right, Sibylle Anderl, who was born in 1981.
La doppia laurea.
She did a double university degree in physics and philosophy in Berlin, and then astrophysics in Bonn. And then until the end of 2016, she carried out research on star formation in Grenoble. And then she worked on topics such as the philosophy of science. Since 2017, she is editor for the national newspaper Frankfurter Allgemeine Zeitung, and she's in charge of the scientific pages since 2021. She also moderates various formats on the German television. On her right, we have Mr. Paolo Costa, who was a guest of Muse many times. I'm sure that some of you already know him. Paolo is a philosopher. He works as a researcher at Fondazione Bruno Kessler in Trento. He focuses on spiritual transformations of modern society, which include various objects which go from the modern concept of nation up to the borders of human rationality and going through the destiny of secularization. And recently, he also focused on environmental philosophy, in particular the spiritual meaning of alpine environments. And he's writing a book on this topic, whose title is, for the time being, Resounding Mountains, a reflection about being in the mountains. And now the floor to our first speaker, Sibylle Anderl.
Thank you, Elisabetta. Buonasera, mi chiamo Sibylle Anderl, prodotto non parlo italiano. L'ho memorizzato. Io sono molto contenta.
So I don't speak Italian, but I'm very happy.
No, I need my own translation.
Sorry.
Sono molto contento.
I'm very happy
Che tu sia qui.
that you are here today.
Molto grazie.
Many thanks.
All right. Now back to English. So I wrote a little book about the philosophy of astrophysics, and I want to tell you about it today. The story of my book started here. This is the Uckermark. It's a region in Germany, about 100 kilometers north of Berlin, and it's very green, lots of nature, not many people. And I went there a couple of years ago together with some colleagues. Some colleagues who were astrophysicists, like me, some colleagues who were philosophers, like I used to be, some historians of science, and some sociologists. And we went there because we needed a calm environment to try to understand how astrophysicists gain knowledge about the universe. So this was the question we were interested in. And we thought that the combination of our perspectives could be pretty interesting. So the philosophical perspective that can understand how we manage to gain knowledge about the world. Epistemology is the technical term for that. Then sociologists, what are the factors, the human factors that determine that endeavor? Like social connections, communication, things like that. And then, of course, the historical perspective. How did this change within time? How did concepts and ideas change? Well, and then, of course, we also needed astrophysicists because this was a topic and we needed the knowledge to discuss. We didn't want to solve all the questions immediately there in the Uckermark, but we wanted to start a scientific project. And in order for that, we needed money. We wanted to write a proposal to ask for the money, and this was our goal in the Uckermark. So, as usual, if you want some money, you have to convince an institution, so the German research institution, to give you some money, and you have to convince them that the program that you want to do is somehow worth the. And so we were looking for arguments for that. And for me, it was pretty clear that our main argument would be very easy. I thought, well, it's obvious that it will be interesting to study astrophysics because astrophysics is a very special scientific discipline. So this was my claim back then, but I was the only one who was convinced that this was the case. My colleague said, well, no, astrophysics in the end is not really special. It's just applying physics towards the universe, towards the cosmos. And so, well, I had to give in and said, okay, then we write something else. Maybe I'm wrong. I still think that astrophysics is special, but maybe it's just because I'm an astrophysicist and everybody thinks that he or she is special, so let's do something else. So, but I kept the question in mind, and I was wondering why my intuition was so strong that the science of the cosmos is something different from other disciplines. One reason why I was so convinced was this. So this is the night sky. And when we look at the night sky, I think we all remember that astrophysics is the oldest human science. Humans have always looked up at night, wondering what's happening out there and what is our place in all that. And the first part of the question, the astrophysical part, so what's happening out there, is something that we are still working on. So we have a very long tradition. At the same time, it's a very hard question because we don't have much information to answer it. It's basically what you see. We get the light from out there, from the cosmos, and we have to rely on the fact that the information reaches us. So just imagine that something is happening out there without sending information towards Earth. We would have no chance to get to know about it. We are passive observers. And this indeed is something different from other scientific disciplines. The experimental sciences, there you can manipulate things in the laboratory. You can try things, you can variate the conditions. This is something that we as astrophysicists cannot do. We cannot create stars in the laboratory. We cannot just throw something into a black hole and see what happens. This would be wonderful if we could do it, but it's just impossible. And so we have a very limited basis of information to gain knowledge. This was one of the reasons. that I had in mind. The other thing is that we are dealing with just extreme times and spatial dimensions. So already the space, if you think about the sun, it's sending light towards Earth, and the light, which is extremely fast, already takes 8 minutes from the sun to reach us. Then the next stars are like 4.2 light years away. The light takes more than 4 years to reach us. Then the center of our own galaxy, the Milky Way, it's about 26,000 light years away. So just imagine if Stone Age men had built a spaceship which could fly with the speed of light, which is impossible physically, then they would have reached the center of our own galaxy only today. And while this is just our galaxy, then other galaxies are millions and billions of light years away. So it's just huge. The universe is just too huge for us. It's hard to imagine these spatial dimensions. And the same holds for the temporal dimension. Well, we as humans, our lives are just so short in comparison to everything else in the cosmos. So stars develop over timescales of millions and billions of years. The universe is 13.8 billion years old. And so we always have to realize the cosmos is just something completely different compared to what we as humans know from everyday lives. But the same holds for the conditions out there. You have extreme temperatures, extreme densities, extreme gravitational fields. It's all so much more extreme than everything we know here from Earth. So these were the ideas that I had in mind why astrophysics is so special. But again, my colleagues thought, well, it's not a matter of quality, it might be a matter of quantity. So I stayed silent about this, but I was even more happy when a couple of weeks later, I stumbled upon a philosophical article that shared my argument. It said, well, astrophysics is really special. This was the article, written by Ian Hacking in 1989. And so I was really happy that somebody shared my opinion, but when I read it, I realized that he shared the opinion for completely different reasons. Ian Hacking said that, well, astrophysics is special because you cannot rely on it, because you shouldn't trust astrophysicists, because they don't produce reliable knowledge. So, of course, this was not what I wanted to hear. Special for the wrong reasons, so to say. But at the same time, I could not ignore this paper, because Ian Hacking is a well-known philosopher of science. He is well-known, first of all, because he initiated the so-called experimental turn. So in philosophy of science, you try to understand what scientists do. And historically, many scientists, many philosophers always focused on theory. So they thought that theory making is the important part of scientific research. And Ian Hacking was one of the first ones who said, well, no, doing experiments is equally important. And it's something that we have to study very carefully as well if we want to understand science. So this is one thing that he is famous for. The other thing is his role in the discussion on scientific realism. Scientific realism concerns the question whether the things scientists talk about are real. Well, it sounds like a silly question if you think about scientific disciplines like ornithology. Well, of course, birds are real, or petrology, of course, stones are real. But if you come to scientific disciplines that deal with things beyond our direct senses, so like quantum physics, the question becomes more interesting. So the question, are electrons real? Are quarks real? Are protons real? These were questions that were discussed for a long time historically. And for good reasons, because if we look at the history of science, we know of many examples where scientists believed in the existence of things, and then it turned out that these things did not exist. So for instance, a chemical element, phlogiston, people in the 18th century believed that this was a chemical element that would explain how things burn. Then it turned out it doesn't exist. Another famous example, the ether. So the medium, the stuff that fills the space. people were convinced that this must exist. But then Einstein came and showed, no, it doesn't. And so there are these examples, and this shows that it's always good to be skeptical and to always ask whether the things that scientists talk about are real or not. So Ian Hacking is famous because he created a criterion how to distinguish things that we can rely on and things that we should doubt. And he said we can really believe in the existence of scientific things if we can do experiments, if we can interact with it. So if we can, for example, use electrons in order to make our mobile phones run, or in order to watch television, then it's a very good reason to believe in the existence of electrons. So he said, if you can spray them, if you can spray electrons, they are real. So, and now, to come back to my original point, it's pretty obvious why Ian Hacking doesn't like astrophysics. Because I already told you, we cannot do experiments with stars, with black holes, with neutron stars, and so on. And so Ian Hacking must say, well, if you cannot interact with them, then we cannot believe as firmly in their existence as we can believe in the existence of electrons or other parts in the microcosm. So this was the thing that he explained in his paper in some detail. I will spare you the details. I will just try to illustrate his argument by means of a piece of art. So this is not the piece of art, this is the shadow of the piece of art. Now imagine you see this shadow and you have to deduce which kind of object the piece of art consists of. So, without any more clues, it seems obvious. It looks like a ship. And now imagine you're an astrophysicist. You only have the shadow, no more data. Then your job is over. Your scientific conclusion is that there must be a ship out there, because you cannot generate more data than the shadow. Now, if you're an experimental physicist, you can just switch the light on. And then you see, it's not a ship, it's just an artsy collection of trash. And this is exactly what Ian Hacking would say is the problem about astrophysics. That sometimes you just don't have enough information to decide whether you really have a ship out there or just such a piece of trash. So this is his argument, more or less. And in my book that appeared also in Italian some years ago, I just spent quite some time to explain why I don't think that this is a good reason not to trust astrophysics. And to keep it short, the main reason why I think that we can still trust astrophysics is that it's true, we cannot do experiments, but we have a different method, which I call the Sherlock Holmes method. So what we do as astrophysicists is pretty much similar to what detectives do. Something has happened out there in the cosmos, and we find traces. And then it's our job to make up a story, a hypothesis, to explain what might have happened. If we have found a hypothesis that can explain the traces, we are not finished, because there might be other hypotheses, just like in the criminal story. So you have different people who could have done the murder. And then the next step is to think, well, if this was the story that happened, what else should I be able to find? Which additional clues could I look for? And this is what astrophysicists do every day. They think, well, this might be a possible explanation, but if it was true, what else should I see? And today we are in the lucky position that due to technological advances, we have lots of information that we can use for that we can use if we look for traces. So today we can look at the full spectrum of electromagnetic radiation, from the very long wavelengths, the radio wavelengths, through the optical that we all know, because this is what we see if we look at the sky, to the very highly energetic short wavelengths, for example, in the gamma regime. And the nice thing about this is that whatever wavelengths we use, we always see something different. So with the long wavelengths, we see the cold universe, the molecular clouds, the very young stars. And with the short wavelengths, we see the hot universe and the very violent processes. And so we have different ways how to see the universe and how to answer the questions that we have. We also have some additional information carriers. We have cosmic rays, so elementary particles that reach Earth from the cosmos, from the solar system. Then we have neutrinos, ghost particles. They are extremely hard to detect. You need huge detectors. So one of them is up there at the top right, the ice cube experiment at the South Pole. This is 1 cubic kilometer of ice. Then we have meteorites, and recently we have gravitational waves, which opened yet a completely new and different window to the universe. And so we have lots of information carriers. So it's true, we are still passive observers, but we have lots of information that we can use. So now we understand many, many things about the universe. We know a lot about the solar system. We know a lot about different stars, about the life of the stars. We know a lot about the Milky Way galaxy. We know how galaxies evolve. We know many different types of galaxies. And maybe the craziest thing is that we even know a lot about the universe as a whole. We know how the universe evolved and how it originated. And this is cosmology. And this might be the most fascinating part of astrophysics. So how do we do this? The universe as a whole. So just in a nutshell, we start with theory. This is just to impress you. It's general relativity, Einstein, what Einstein wrote down. It's beautiful equations, but they're really complicated. They describe how matter and space-time interact. And if you apply this to the universe as a whole, you get possible world models, so possible ways of how our universe could be like. And then you combine this with data. For this, you mostly use the cosmic background radiation. It's this big egg that you might have seen somewhere. It's often called the baby photo of the universe. And if you combine both, you really get a model that describes our universe. And this is something that you might all have seen already now. This is what we think our universe is like. It started with a Big Bang, 13.8 billion years ago. Then there were some dark ages where it was just dark, no light. The light was just moving through the universe. But then after a few 100 million years, the first stars were formed. And they formed galaxies. These galaxies evolved. And then at some point in the Milky Way, our solar system was formed. And finally, we as humans were evolving on Earth. So this is the picture that we have. It matches pretty good with all the data, but it also has a drawback. And this becomes visible if we ask ourselves what the universe consists of. So what is the stuff that fills the universe? And this is the answer to it. And the sobering answer is that only about 5% of everything in the universe is matter, like you and me, like Earth, like the things that we know and that we understand. And everything else, 95%, is stuff that we do not understand yet. It's dark energy. This is the stuff that leads to an accelerated expansion of the universe. And it's dark matter. This is stuff that has gravitation, and it's needed in galaxies and to create structures. So the whole universe would look different without dark matter. But still, we don't know what it is. And so this is our cosmological model today. And this yields us back to the beginning, because I think that it creates a feeling of humility for us humans, because we see, well, we know a lot today. We have learned so many things. We are in a golden age of astrophysics, but still we face huge open questions. And still, it's very surprising that we as humans are able to understand the cosmos and to find laws of nature that we, with our very limited human consciousness, can grasp and understand. We see order in the universe. And then the next question is it human order? Is it something that only we see? Or is it universal order that maybe also aliens would see, or that people in a couple of 100 years would also see? I think this is a very fascinating question. If we would imagine that we could talk to people living in 500 years from now, what would they say about our science? Would they say, well, given their limited technological possibilities, it was not so bad what they were thinking? Or would they say, oh, it was really, really wrong what they were believing back then. How could they be so stupid? So unfortunately, we will never be able to answer this question. But I think this is a very nice thing about astrophysics, that it shows us that, our position within history is maybe not as strong as we believe and as we think. And still, if we look at the night sky, we still have the same questions, probably like many people before, about what the cosmos is like and what's our position in all of this. And I think with this, I would like to hand over to Paolo Costa. Thank you.
Grazie a Sibylle Anderl.
Thank you, Sibylle Anderl. The book that she authored is The Universe and I, L'Universo e Io in Italian, and TP di Solferino is the publisher in Italy. Now the floor goes to Paolo Costa. I would like first and foremost to thank the Muse Museum for inviting me to participate in this very special event. As Elisabetta said, we really have to take every opportunity we have to mix knowledge, to exchange knowledge. I think that Sibylle has been wonderful in conveying to you this sense of the intellectual adventure, which I believe is absolutely typical of cosmology originally and astrophysics, and which probably makes astrophysics the most fascinating science of all. So I will also try and speak slower than I would do, so that I can be translated into English. And it is a privilege, I think, that I can speak Italian, so I will use this opportunity, but I will speak slowly. I think that you understood very well, based on what Sibylle said, that at the very center of her philosophical also argumentation, there is an element which which makes us proud and concerned at the same time. That is the idea that astrophysics is something special as a science. And since I am a lay person in this field, I can confirm that I see something special in astrophysics. And this has to do with the extraordinary, astonishing aspect of this field, which sometimes puzzles us: galaxies, black holes, the Big Bang, the continuous expansion of the universe, stars that are born and die, and then imperceptible cosmic radiation. And this constant reference to elements which are very far from our common sense, so to say, and which astonish us, which test our very experience and our way of looking at things. I do not think that this is a chance, that by chance the explanation of the movement of the stars and the focus on the size of the forces acting in the universe are the field where a scientific revolution in modern times took place, and capturing the attention of people. I think of Galileo Galilei and Kepler. And this, of course, has consequences. And possibly I will go back to that at the end of my intervention. This special quality of astrophysics is obvious for Sibylle, so much so that in her beautiful book, she successfully shows that many of the tools of knowledge that we can use help us understand extraordinary things that, as a matter of fact, are far away in time and space, and they are also used in experimental sciences, as a matter of fact. And this is something that she evidences. While listening to you, I was impressed, as I was when reading your book, by one thing. Within this framework, which is absolutely controlled, the
ha una sua qualità umana molto.
voice of the speaker, the authorial voice, has its own characteristic, cheerful, sometimes light-hearted, as when you
Che nella lingua inglese to model
play with the meaning of the verb modeling, which means being a model and also making a model of something. And so I found that very nice. Playing with words is very nice. And at the end of each chapter, there is also a dialogue with her parents, which could also be very similar to the dialogue that we can have tonight. So, as a philosopher and as a person who is passionate about philosophical aspects and also in anthropology, I find this especially fascinating, and I will try and explain why. Well, I believe that the starting point is the following. We never reflect enough on the impact that the new vision of the cosmos has had, not only on knowledge after Galileo, but also on the imagination of modern individuals, and our capability of having a consistent picture of what is explained to us and what it means to live in a universe with this picture of cosmos as described by post-Galilean science. This is another aspect of the question that we deal with tonight, and which makes us understand the reason why we have something special in astrophysics. I believe that this characteristic, this second form of being special of astrophysics, is wonderfully captured in the title of your book, which is The Universe and I.
Well, I like the sound of the conjunction in German, that is und. So the importance of the universe and its relationship with us. So now let's do apart one of the most obvious forms of knowledge, that is religious symbolism. So let's forget about that, because religious symbolism has always had a fundamental point of reference in the sky. But we know that the celestial vault has represented throughout the millennia a sort of a map or a mirror where the most curious people have looked for a solution of the riddles of existence, the enigmas of existence, or of a possible consolation for its infinite pains. It's as if this enabled us to fly away from things which represent a pain for us. Well, one interesting aspect of this relationship with the cosmos that human beings have always had for centuries is that the cosmos has an effect on us. So its width, its stability. Well, think of the constellations. Sometimes we think that we see some laws, some natural laws in the cosmos. So the definition that I propose to you is that this very special science has this very important duty for us human beings. It helps us get in a connection with the background, which makes
Il fatto di poter
the impression of this experience even more unbelievable. I don't know if you have the same idea, but you know, the idea that there is a place to which we have access where all the things that are in the cosmos and all the things that are with us, well, all these things get together. Well, this is the thought, this is the intuition, most impressive intuition for a philosopher. I like to read, among the many examples that we could make, a passage of a poet, a philosopher, a poet, Czesław Miłosz, a Polish poet that I like very much. And at the beginning of a book called Visions from San Francisco Bay, he says, he writes,
Sono qui.
I'm here.
Queste due parole
Those three words contain all that can be said. You begin with those words and you return to them. Here means on this earth, on this continent and no other, in this city and no other, in this time that I call mine, this century, this year. I was given no other place, no other time. And I touch my desk to defend myself against the feeling that my own body is transitory, is transient. And then he continues, I have written on various subjects, and not, for the most part, as I would have wished, nor will I realize my long-standing intention this time. But I'm always aware that what I want is impossible to achieve. I would need the ability to communicate my full amazement at being here in one unattainable sentence, which can simultaneously transmit the smell and texture of my skin, everything I stored in my memory, and all I now ascend to, descend from, etc., etc.
La poesia è il mezzo con
So you see, poetry is the means by which human beings distill their experience through language. So quoting of a poet was almost compulsory in this case.
questo incontro.
Well, while I was preparing this meeting, I was sort of touched by a song that you perhaps know by Cristina Donà, which arouses this special feeling that we have when we connect the cosmos with our intimate experience and personal experience. So when we reflect about what really matters for us against the unlimited space of the cosmos. I don't know if you know the song, but she says, inside a vertigo that dances and takes us beyond the time until we fall back to the lips, and the enchantment is the same.
Ma dentro di me non c'è solo una Cristina.
Well, inside myself, there is not only this song, but also a colleague who would immediately tell me or ask me, but what does all this have to do with science?
Drastica.
A very drastic question. And indeed, from good scientists, we expect something else than just poetry. We ask for reliable information, evidence, incontrovertible evidence, sophisticated theories. And in the book, Sibylle shows in a very understandable way the way in which you mix models, experiments, tests, and the objective is to have explanations, rigorous explanations, and not the kind of wisdom that probably in ancient Babylon,
si sono messi sistematicamente
the first people observing the sky took for contemplating the skies. So the final question that I offer to you and also to Sibylle is everything limited to this? Is there no way today to make scientific knowledge a form of wisdom similar to wisdom through suffering? There is a fine expression in ancient Greek which sounds patsai matos, that is, the knowledge by means of suffering, that is, to know how to be touched personally. This is a sentence of Aeschylus, Agamemnon. And my Greek teacher at school used that sentence because she wanted us to understand Oristus, the third declination. But really, that means to know things by means of experimenting suffering and other things that we do. So giving up wisdom, is this the inevitable price that we have to pay in order to have this extraordinary knowledge of things?
Secondo me, appunto, per rispondere.
So to answer this question, we need to be clear about the meaning that we give to the virtue of wisdom and what makes it different from knowledge. And so I propose a hypothesis about the main characteristics of a wise way of being in the world. I offer these as two attempts. So first, what characterizes virtue? Well, the ability to do justice to the largest number of viewpoints, even the more marginal viewpoints. So by stretching as much as possible the point of balance where we have the feeling that we can rest in our reflective efforts. So we stop and we say, okay, we put together everything that we could put together, and we did justice to all the sources from which we take our sense of reality. So this is a first definition of wisdom. And the second definition of wisdom is that, well, wisdom also includes the ability to tell a story about ourselves, an enlightening story that can transform this mindset. So it transforms it in something better, more creative, and perhaps a less destructive way of being in the world and of being together with others. So I imagine a wise story putting together the Big Bang, but also our afternoons and nights of glory or of suffering when time never passes. Think of when you wake up at 3 in the night and you cannot sleep again because you have many thoughts. And I'd like to quote a philosopher, a German philosopher, Walter Benjamin, who, in an essay dedicated to narration, said that wisdom is the epic side of truth.
Bene, chiudo qui.
Very well. I'll close here.
Sibylle, da quello che io...
So, from what I read in the book and from what I listened to her here, well, I had the impression that she too, from the sky, apart from knowledge, she also expects a bit of wisdom. And in the complicated things that she describes in the book and that are generated by nature, well, if you think also for her, the starting point is that from a very small corner of the universe, we try to know the whole of the universe. So from this very particular relationship, she perhaps also expects a bit of wisdom. And so as a layman, the question that I would ask her is the following. Is the separation between knowledge and wisdom, which is a typical product of scientific revolution, is this really the last word on the subject? Is it really pointless to hope that the study of the universe may make us a little wiser and perhaps even prompt us to enter into a new alliance with nature? If not so, at least a sort of mirroring, the one that I described earlier, which may rely on a variety of tensional resonance with what surrounds us. And perhaps from this new alliance, knowledge-based alliance, perhaps we can expect what everybody expects to have, that is, to change for the better. Thank you. Many thanks, Paolo Costa, for your contribution. Paolo Costa always says something very interesting about sciences as a philosopher. But as I said at the beginning, also Sibylle Anderl is a philosopher. So I'd like to start from the question that Paolo raised. In your opinion, astrophysics and the study of the cosmos can make us wiser and potentially closer to alliance, closer to a new alliance with nature. Is this possible?
Well, first of all, I think it's true that modern research is very knowledge-focused. So it's it's a lot about calculating, a lot about models, a lot about getting reliable results. And if you are part of research, this really dominates your work and what you are doing. And it's a curious detail of astrophysical work that you rather get detached from the sky. So for instance, if you go to a distant place, to a telescope, for instance in Chile, in the Atacama Desert, when you observe the sky, you are sitting inside in a closed container in front of your computer and you don't see the sky at all. And so this maybe is a kind of picture for the dangerous process of modern science. It's dangerous in the sense that that researchers tend to get detached from the whole, from the full picture, but at the same time, this focusing makes science so particularly successful as well. So, getting to your question, I think astrophysics is a very nice discipline to make the different, the reverse direction from knowledge to wisdom again. Because, as I already mentioned, it is a very human science, very human questions. Everybody knows the look into the sky. And this is something that every astrophysicist gets reminded of again when he or she communicates with the public. Because these are the questions that we are basically asked. It's the questions from everyday life. And astrophysicists need communication in order to get back this original view onto the universe again, I would say. And at the same time, astrophysics is a very nice discipline because it has this very strong and, the very long heritage of cultural activities from humans in exchange with the cosmos, so to say. So there is this whole history from art. The universe has always inspired artists in music, in paintings, and so on. Then, of course, there's religion. Our place in the cosmos was always an important point. Then, there is the history of worldviews, so the philosophical aspect. And so astrophysics is a kind of focal point where many different human activities come together. And I think this is the view that somehow goes in the different direction from the increasing focusing and splitting of scientific research. And I think it would be important to retain both, to also save this holistic view onto the world. And so I think your perspective and your thoughts are extremely important. And I think many scientists would also agree that it's not good if every scientist only does research deeper and deeper in a very limited part of knowledge and does not look into other directions anymore. And I think many people have understood that, and philosophy is a beautiful discipline to remind scientists of the things that they may have lost in this ever-growing specialization nowadays.
Se non ti dispiace, Paolo, ho un'altra domanda.
Paolo, if I may, I have another question for Sibylle, because we said philosophy is wonderful, astrophysics is even better, but Sibylle said earlier on in her presentation, her contribution, that we only know 5% of what makes out the universe. So am I the only one who feels that this is terrible, as a matter of fact? Am I the only one concerned by this?
Well, scientists love open questions. They really like riddles and puzzles because this means that there's something they can find out. And so I agree, it is bothering everybody that the questions are so huge. But at the same time, there's still optimism in the community, I would say. First of all, as I said, because it's interesting things to work on. And at the same time, because we really live in the golden age of astrophysics. We have so many new observational programs, so many exciting missions, so many new things that we understand. So here we see the first picture, for instance, of the black hole in the center of our Milky Way. This was just released a couple of weeks ago. Then we have experienced the first detection of gravitational waves. We have already in the past years, we had a number of Nobel Prizes going into astrophysics. So many things are happening right now that I think, even though it's an embarrassing fact that we only understand 5% of the universe, we are still very optimistic, and so we are not depressed at all.
Grazie allora, Sibylle.
Thank you, Sibylle. So if you have questions, and I'm addressing the audience, raise a hand and ask them. I have a number of questions, though. I have a technical question to Paolo as a philosopher. Philosophy, in your view, does it help us understand the universe, and can it also help science, or is philosophy per se something which has to refer back what it says to its own scheme, so that it has only one viewpoint? Philosophy has the same problem, so to say, that science also has. Sibylle correctly and beautifully explained what the scientific modern endeavor consists of, which is based on cumulative collaboration. It requires many people joining efforts, as is the case in industrial production. There is a division of labor and of tasks, and a number of tasks may also be boring, but they are fundamental for the overall progress of the collective endeavor. This is where progress comes from. Think about what happens when you work tirelessly, you really are engaged and you make an effort, and then one day you stop and you ask yourself why you're doing that. Well, that type of question no longer has a place in a scientific community. It is as if we were to think of a professional place where we can ask this question, meaning, why are we doing this? Where do we stand? What does it actually mean that we only know 5%? What is the meaning of that if we compare that to the overall picture? Well, I think that one of the very tasks of philosophy is not so much that of providing an answer to these questions, but keeping this space of questions alive. and open, so much so that we all can enjoy that, so that in our leisure time, as well as Sibylle also explained, referring to a place which I also saw when I was in Berlin, and which is something which really means larger horizon. And I think of the flat land around Berlin. So let me go back to the point. I think of philosophy as a space, and our task, as in our capacity as philosophers, is to keep it tidy and orderly with the instruments and tools that we also need coming from the history of thought, so that people working in different disciplines can enter this space and ask the question, why are we doing that? Why are we putting so much effort into what we do? Why do we carry out extremely boring tasks? Sibylle is very good in describing things. And you imagine the work of astrophysicists as the job of someone who sees wonderful things making great pictures. But actually, Sibylle tells us that it is not so, that you have to make very complex calculations that computers also can perform, and that you have to really work hard. And this brings us back to Bacon's discovery. That is, science is made all hard labor as well, of toiling about things. And science is what it is because there are so many people who humbly work and perform also boring tasks, while others have the big ideas. So I think that the task of philosophy is this one. Make it possible for us all to ask the question that we said. Well, thank you, Paolo. Thank you, Paolo Costa. Now I have another question to Sibylle, but perhaps you wanted to comment what Paolo said.
Maybe just to add, there is this mean but nice saying, philosophy of science is as useful to scientists as ornithology is useful for birds, which I don't agree with at all, because exactly for the reasons that Paolo summarized so nicely. Philosophers are very good at understanding things. They have very sharp concepts, and so they have the tools to understand and to reflect on the things that scientists are doing. And in that respect, they are much better, and they are much better equipped than the scientists themselves. And so from my experience, it's always extremely fruitful to get into interaction. But of course, it's always a difficult question whether philosophers of science or philosophers in general really contribute to scientific progress, because the first step is to confuse scientists, to make them question things they do. So the first phase would be a deceleration of scientific progress. But I think in the end, it achieves a higher quality of scientific research. So this, well, I have to say this because I studied both philosophy and physics, but I deeply believe this, that the interaction is very fruitful and very important.
Sibylle mentioned Ian Hacking, who is a philosopher with the very features and characteristics that she described. He is very precise, very smart, but also writing about interesting and funny aspects, dromomaniacs being one. That is to say, a syndrome, a psychological syndrome back in 1800. And then he also wrote about other things which are extremely strange. And we both recommend you reading Ian Hacking if you want to discover a side of philosophy that you would not imagine is there, because he is really capable of combining the empirical aspects with the most theoretical, dreaming activities, and he is extensively translated into Italian. A question to Sibylle, because because in your presentation, you mentioned the fact that oftentimes astrophysicists work as Sherlock Holmes. And in 2019, we had the first picture of a black hole. So did you feel a bit like a detective whose theories are confirmed? Were you happy? Were you satisfied due to that picture that was published?
Well, yes, I was extremely satisfied, I think, like everybody worldwide, because it's such a beautiful picture. It's not the best example for the Sherlock Holmes method, though, because there it was relatively clear what the scientists expect to see, because black holes are intrinsically boring, so to say. So they just have a few properties, and there's not so much to, well, it could still have been that Einstein was wrong and to see something completely confusing, but the surprise was not as big. But still, it's a very nice example for the extremely hard work that is part of astrophysics nowadays. This ring that really doesn't look that spectacular to laymen who don't know anything about it, well, it's just an orange donut, basically, is extremely complicated because it was created from the data of telescopes that are located everywhere on the world. And so the data had to be combined. And this combination, I think, is the most complex way in astrophysics how to create images. And the scientists needed a couple of years to really get this image. And the Sherlock Holmes method may have come in the sense that they really needed to be sure that they don't make any mistake in the data reduction. Because, because you create or you simulate a big telescope with the size of the Earth. But at the same time, you don't cover the full Earth, so you lose information. And this is the general problem that they had to solve for this picture. They had to recreate the information that was lost in between the telescopes, so simply spoken. And so it was an extreme success that they really made this picture, and it just shows the incredible progress that astrophysics is doing recently, and that we can really see things. And it shows another interesting thing, and this is a more philosophical point. We already knew a lot of things about black holes before. We already knew that there is a big black hole in the center of our galaxy. The Nobel Prize went to the US and to Germany for that last year. But the general public was not as enthusiastic about these pieces of knowledge as they were about the image. And this shows that we as humans always need pictures. We need to see something. Because the Nobel Prize was awarded for research where the existence of the black hole was deduced from the orbits of stars in the center of the galaxy. So it was a rather complex way of inferring the existence of the black hole. And so this was not as convincing as such a picture. And this still shows how much, well, human properties are there in science. So science is still a very human activity. And that we need images, and that this is the power of astrophysics. To have such nice images also shows how humans think and how humans manage to understand the world around them.
Paolo, Sibylle, quando ci spiegava.
Paolo, when Sibylle explained to us what the detective investigation work is in astrophysics, she referred to her own discipline. Do you think that philosophers also look for things, or do they only create things?
Mi ricordo quando ho scritto il libro La ragione so io.
Well, I remember when I wrote the book, Reason has its excessive indications. I was invited to a meeting, and when I was introduced, well, the moderator said, okay, the philosopher that emerges is that of a little mouse. You know that little mouse gets a lot of fun by running on the wheel. They make a lot of movement, but they remain always still. That was not so far from truth, because sometimes scientists say that philosophy is not cumulative, meaning that the time comes when you're no longer interested in the things that have been discovered in the past. We continue to read Plato, for example, and for scientists this is a bit strange. Well, but when I heard that philosophers were like hamsters, well, I had the idea that we were like an astronaut in the space of reasons, like a person who navigates in the space of reason, which is the natural place where philosophers live. It is the space of reason, that is the space of immaterial things, which determine our differences, our thoughts, and we find them, and sometimes we have access to those things simply by means of actions or emotions. So for me, philosopher is an explorer, a big explorer, but well, this is something that we discover with time. The other people do not find our job so passionate. So, of course, you have to find the right things. But yes, let's say that the space where we live and which we like to explore, also because it is inoffensive, is the space of reason. Well, it's a form of cosmology, if you want. Well, the great continent that you mentioned at the beginning is thinking, thought. Well, I don't know if I managed to transmit our surprise. Well, surprise means that we can imagine that place, which is difficult to explain in an objective way, that is in order to create evidence. But we call it conscience, but conscience is not the right word, because, well, we think of conscience as attention, but this is not the case. This is a space where all these things get together. All the things that we're speaking about this evening, they are all there together. Think about that. Well, the idea, well, Plato, for us, is very important. When he spoke about the world of ideas, which is irritating when you're 15 years old, well, he didn't mean that we have to dematerialize, that our body is not important, that only immaterial things are important. Well, he wanted to show his surprise, because there is a place where all physical and non-physical things stay together simultaneously. Well, Plato had understood something that for us is still extraordinarily important. So this wonder, this satisfaction is very similar to the satisfaction expressed by Sibylle when she transmitted and when she shared with us her passion for science. She's a passionate scientist. Do you think that passion and being a scientist are two things that are closely connected, or do you think that scientists do not love passions?
Well, I think without passion, you cannot be a scientist. It comes naturally together because the starting point is always curiosity. And I think curiosity and passion is also something that often comes together. It also is mandatory because being a scientist is hard. It requires hard work. You have to work a lot under conditions that are not always optimal. And so if you're not passionate, I think science is not the right job for you. So this is the sad reason. But the good reason is that it's just extremely exciting to be in a position where you can answer your questions, where you can go out and try to find new things. And well, I liked Paolo's picture a lot, that philosophy is similar in the sense that we go out and well, explore the space of reasoning, because I think it is similar in a way. There are some books that are really hard to read, where you need to really be patient, and also where you need passion, not to get frustrated immediately. For instance, if you read Kant or Hegel or all these old classics, it's nothing that is easily accessible. But still, if you invest some energy and time, then it really opens up a new world and you discover new things. And so, well, it's something that I liked a lot, to see that it is parallel. So I think passion for philosophy is equally important, maybe. And for me, I always found it more, well, I studied both. I studied physics and I studied philosophy, and I personally found it harder to study philosophy than studying physics, because when you study physics, you can always say, well, now I understood mechanics, check. Now I can do quantum mechanics, check. In philosophy, you never reach the stage where you can say, well, now I understood Kant, check. I understood Plato, check. Because you always think, well, I'm still searching for the answers, and I made some progress, but, well, the answers are still there. And so I think philosophy is the much harder subject compared to physics. Maybe for the young people in the audience who still have the chance to choose.
Se posso aggiungere...
Well, if I may add a comment, what is really satisfying and gratifying in this sense is that also with some years later, philosophy understands things well. Perhaps you read the critics of pure reason or Plato, for example, and suddenly you understand something that you had not understood when you were at school or at university. So what's really beautiful is this endless dialogue. And of course, this is our long-standing tradition, but it's like being always there, as if we were always sitting at the same table. Well, we are Italians, and we know that we like to stay at the table and speak with people. So the idea that the time will come when things that you studied in the past will become immediately clear. Well, for science, this is a bit difficult because there are other forms of satisfaction. And also because maths has a language which enables you to formulate questions and give very accurate answers. So there is a major difference. Maths makes the difference, of course. But also maths is a language in a way, and it's not so far away from this thing that we cannot define and that we call thinking. Now, questions from the audience? Could you raise your hand and speak in the microphone?
Buonasera, grazie.
Good evening.
Spero di non fare una citazione sbagliata, vado a memoria.
Well, I hope I will not quote badly. Popper spoke about a space of metaphysics in the construction of physics. So let's think of Einstein, for example. When I think about an explanation of a given phenomenon, mentally, I am at a different level as compared to the neuroscientific instruments that I have available. And so my question is the following.
Questa visione. Quanta metafisica c'è?
So how much metaphysics do we have in current astrophysics? Well, in the theory of strings, for example. So this is my question.
Grazie.
Yeah, thank you. That's a very good question indeed. It's interesting because there was quite an intense discussion in cosmology a few years ago on whether Popper is outdated. So Popper has this criterion that, well, in order to have a scientific theory, you need some elements that can be falsified. You need to be able to do an experiment to show that the theory is wrong. And if you take some very complicated theories like string theory or other theories that try to bring together gravitation and quantum field theory, then you have the problem that these theories are about conditions that rarely occur in the universe. So the typical conditions are black holes or the Big Bang, and that are impossible for us to create in laboratories on Earth. And so you have a fundamental problem if you want to apply Popper, because it's not easy to test these theories. And so scientists were discussing whether we should say, well, Popper was a great philosopher, but he could not foresee the future. And so we need different criteria. We cannot apply Popper anymore. And I think it's a very important discussion to have, because I think it's extremely dangerous if you accept mathematics and just mathematical beauty, so to say, as the criterion for truth in science, and not anything empirical anymore. But if you still want to apply Popper, then you probably have to say at some point, well, there are questions in the cosmos that we cannot answer scientifically. And this is also something that we are not happy to accept. And so it's an interesting situation that we face now. And it shows again how close modern physics and modern sciences are related to philosophy. Because in the end, these are philosophical questions. What are the fundamental boundaries of science? And so I don't have an answer to this question. I am an observational astrophysicist, so for me, empirical data is always important. But, well, I know many colleagues who have different tastes, so to say. And, well, it is interesting, and it's a philosophical question in the end.
Grazie. Abbiamo una domanda.
Thank you very much. There is a question written from a person who follows remotely from home. The enormity, the enormous size of the universe and the strangeness of a number of theories, such as of parallel infinite universes, well, they can cause us concern and anxiety as well. Have you ever felt the same, this deep anxiety almost feeling? It's a question for both of you. Well,
no, stavo per dire banalità, però diciamo una delle frasi che...
One of the sentences that we tend to repeat as philosophers
La nostra disciplina è questa idea, no? Che la filosofia
is this idea that Aristotle and Plato said that philosophy comes from astonishment, but some may say that it is fear, it is dismay, it is things that can coexist. This is what you said too earlier on. We had this feeling during the pandemic. Philosophy is something that we can also use as a defense against something that we do not know. Because if you do not know, you do not control. Meaning that there are a number of aspects of our real world that can create a twofold feeling, which is astonishment, surprise, which is something which is expansive, and dismay. Shock even, which is something that goes in the other direction. My impression from the outside is that cosmology and astrophysics conserves something of the original theory, so to say, that we have in our tradition, which is as a theory, as a form for contemplation, because the phenomena that are studied are so huge when compared to our daily life that we can also observe them from far with a sort of detached attitude. It is true that the sun sooner or later would die out, and this can also cause panic if you think about it, but the time frame is so big, so long, that we do not feel it is part of our daily life. So you can look at the abyss and you do that with the same pleasure that you feel when you watch a horror movie on TV, but you know you are safe in a way. So it is detachment in this case that plays a role, I would say, in defending ourselves against the panic. And Massimo Bernardi, I have been speaking with him for 15 years now. We have this intellectual relation, so that when I studied Darwin, we exchanged ideas about the deep time. You know that the theory of evolution is a scientific theory, but it is also a story that we tell ourselves as a species. Telling a story, a narration about such a diluted time, so much so that things seem to be static, is strange. It is astonishing to me. And this is the philosophical awe that I referred to earlier on. And with Massimo, we share this passion for deep time, the long time of biological transformations, and the challenges in terms of knowledge that derive to us due to the fact that this time is so long, if you want to think about all the consequences of this strange object we scientifically talk about. And what about you, Sibylle? Have you ever felt fear or awe or shock?
That's an interesting question, because it's definitely true that detachment is an important factor in this, and especially as an astrophysicist, you lose the fear of the big dimensions because you can easily control them with mathematics. You just put some exponentials there, 10 to the 200 or whatever, and then you have a control, you have a number, and everything is fine. The fear comes back if you want to relate this to everyday life examples. So if somebody asks you, what does it mean? So explain to me, what does this number say? And then if you try to explain it with, I don't know, grains of sand or whatever, then you realize how huge these numbers are and how incredible they are. And I think this is where the fear sometimes comes from, because it makes clear to us how limited our human intuition is in relation to these big dimensions. So for me, again, as an astrophysicist, I came from the other direction, so I lost my fear using mathematics. But I think the first time that I had felt a similar fear, interestingly, was in the context of religion. So I grew up as a Catholic girl, and when I heard at church the first time the concept of eternal life, I found it deeply frightening. The idea that life would never have an ending, for me, was just terror. And so I also got used to that idea, and so now it's fine. But so this was the first time where I think I had this feeling. And again, I think, and this is something that you can also find in philosophy, for instance, in the Critique of Pure Reason, infinity is something that we as human beings are just not equipped to deal with. And so whenever we find something that is allegedly infinite, be it an eternal life or the universe, which is nearly infinite, if you really try to let it get to you emotionally, then it is frightening indeed.
Grazie Sibylle, ci sono altre domande?
Thank you very much, Sibylle. Are there additional questions? I do have a question then. Earlier on, in your latest answer, you said that we are limited in our capability of thinking, of imagining things, so that concepts such as eternal life or the infinite are very difficult to communicate to people. because 2 days ago, on the 12th of June, in many places and in various forms, we celebrated the 100 years after the birth of Margherita Hack, a great Italian astrophysicist who devoted so much time to dissemination, to scientific dissemination. You made a similar choice. So what about the difficulties that you encounter when you need to communicate concepts which are not easy to grasp to common people?
Well, it is not an easy endeavor, that's true. But you always have to anchor things in everyday life experiences. And you need to find analogies, you need to find pictures, stories, things that just show you the basic mechanisms that you want to explain. And I think it's a very important task nowadays, especially, to bring scientific knowledge back into the public, because it's a very dangerous development if scientists just do the things for themselves and do not take the effort to explain things to everyone. And especially in astrophysics, it's easy because most people somehow are interested in these things. Everybody has had a look into the night sky, especially in nice places like here when you are in the mountains and it's just there. So there is a basic curiosity. So this already helps. And what is also helping a lot, I already mentioned it before, is that we have the greatest pictures of all scientific disciplines. So we can show things. And then also science fiction, of course, is a nice way how to explain things or how to raise curiosity and interest. And again, also in that respect, we live in incredible times because, well, space technology is developed very fast. We have new visions. We go back to the moon. People are talking about Mars. So this is also something I think that people like because it allows them a way to, to get out of their everyday life problems and everyday life routines. And this, again, may be also related somehow to the wisdom part, because it's important that sometimes you really find the space to step back a little bit and look at your normal life, your normal problems, your thinking routines with some distance. And then sometimes things that sometime before appeared very frightening and big and important, then get back into normal shape. And this is something I think where astrophysics can help. It can also help to go into the mountains, go hiking, to go into nature. And this again is a point I think where it's obvious that astrophysics and the science of the cosmos is not just knowledge, but it also is very close to what Paolo would call wisdom.
E se posso, non so se anche per voi è così, però secondo me il successo di Carlo Rovelli ha a che fare con un'altra caratteristica del suo pensiero, che è la gentilezza. Secondo me è una virtù che non è tanto valorizzata nella scienza, però c'è una capacità, appunto, che è una forma di tatto, se ci si pensa bene, che ha a che fare proprio con questa inclusione, no? Sibylle prima ce lo diceva, sono le domande più difficili, in fondo sono sempre le domande più ingenue. E questa verità che si nasconde, questa è un'affermazione molto gentile, secondo me. La gentilezza nella scienza è una virtù sottovalutata.
Non solo nella scienza, sono contenta che tu l'abbia citata perché è sempre estremamente utile in ogni campo. Abbiamo visto che appartiene anche
No fields. Can you hear me? Sorry. Okay. They are speaking about kindness. So we have seen that kindness has been recently included in some spots, in some media. and I hope that kindness will come back to us. Well, earlier on, I mentioned Margherita Hack in my question to Sibylle. I would like to say that the multimedia room on the first floor here at Muse is dedicated to this great astrophysicist. And in the park of the Muse, 2 days ago, a show was inaugurated called Space and Our Planet, an exhibition which was proposed already in other contexts. And it is a show about how space innovation has promoted economic growth, sustainable development, gender equality, looking at the same time pioneer solutions for ecological transition, and then last but not least by creating partnerships between nations and governments, that is between people of the world. And on this I'd like to go back to the speakers, but I have a question coming from our YouTube channel. Is it possible that scientists have cognitive cliches or prejudices which find their roots in religion, art, or culture? Because I think in particular about the passion about symmetry.
Well, that's a very good question. It's maybe even more a philosophical question than it is a question to me. But the answer is yes, of course. There is a very deep rooting of scientists, of course, in their time, in their culture, in the way of thinking, in the way how concepts are used in everyday life. And it's very interesting, and again, this is something that philosophers of science do together with historians of science, to follow this in the history of science and to see how the general cultural thinking had an impact on scientific results. And if we see this in history, of course, it would be completely naive to claim that today it's a different situation. Of course, we also have many prejudices. We are heavily impacted by everything else we believe and we know. Still, we have to say that science is a very successful method in obtaining reliable results. And well, today it's very fashionable to think in that direction, that everything could be completely different and science could be different and we could all think different things and it would be equally valid. But well, I think it's a very strong argument to say that today, well, it might be, and we can be certain that many things about science today are just wrong, but still science is enabling a surprising variety of technology. Things are just working. We can call each other with mobile phones. We can get questions from YouTube. And all this is based on science. And so this, I think, shows very convincingly that science has something. So it cannot be completely wrong. Even though it's true that the impact of cultural factors is always very strong. And it's part of doing good research, I think, to always question yourself and to try to find your own prejudices and possible errors and mistakes that you do.
Paolo, vuoi dire la tua?
Sì, ovviamente.
Paolo, would you like to add something? Yes. Of course, the most significant prejudices are those related to the brains. Here in Trento, we have Giorgio Vallortigara, who could answer this question in a very smart way, intelligent way. Well, like Sibylle, I too am struck by the intelligent way in which we human beings and we're animals, well, we can manage these cognitive biases or prejudices. And Sibylle is right. It's very fashionable today to focus on cognitive biases. And it's surprising the way in which we can control them by means of maths or detachment. that is, practices which help us get away from those biases. And for a philosopher, well, you know, we have access to this space. Well, poor interpreters, we can use de-encapsulated or disembedded reasons. We can play with reasons independently on the from the context from which we took those things. We are animals, and so we take those things in a very utilitarian way. But it's incredible. We can do things based on these reasons, and by which we produce knowledge, which in most cases is not useful in practical cases, and so it does not respond to the original biases or prejudices. So this is a reason for astonishment, not dismay, but expansive, positive astonishment, I would call it. And that's why we admire science as a big cognitive discipline. Well, when we say scientific community, well, people think that the scientific community is the all the scientists existing in the world, but scientific community is an institution. It's an invention with its own practices, virtues, rules, which are used to limit the negative impact that cognitive biases have of our understanding of the world. So the scientific community is an extraordinary human creation.
Grazie Paolo.
Thank you, Paolo. Now, one question for you. Well, we spoke about the look into the immensity of the sky and immensity of human beings. Well, the book that you're writing has a different focus because this inspiration is found in the mountains. Why? Have you changed the direction to your eyes, to your gaze? Well, when one gets older, well, one is less fearful of his or her own community. And so I went to look for the source of my passion, for my philosophical vocation. And while writing this book, I realized that most of my curiosity for the world was born in the mountains. Well, I am the son of two parents who migrated from from the mountains to Milan. I grew up in the city. I grew up in Milan. And perhaps some of you know this theory of sociologist Sibylle, who explained the character of citizens that he called the snobs, those who are detached. Have you an idea about that? The classical Milan citizen, always a bit cold, detached from other people, a bit snob. And Sibylle explained that a metropolis is full of useless stimuli. Well, my impression as a kid was that I was growing in a world where stimuli were controlled, while when I went to the mountains in summer with my grandma, I was in a completely different world where there were a lot of stimuli. I did those walks with my father, and every meter my father stopped and indicated something, a flower, a stone, a tree. So it's like an expansion of experiences. And so the comment that I wrote, I took notes of it, of this poet, Louis Gluck. Let's see if I can find it. She says,
dice in inglese, we look at the world once in childhood, the rest is memory. Guardiamo al mondo una volta sola.
So we look at the world only once when we are kids. All the rest is memory. Well, Heidegger taught us that recalling is a bit thinking. So this book was, for me, an opportunity to go back to that experience as a kid, which perhaps is the same experience that Sibylle has when she looks at the sky at the vault of the sky, and she feels that astonishment towards what we can know. Thank you, Paolo. A very final question for Sibylle, a pop question. It's a point of curiosity. So, the day in which we will have an extraterrestrial meeting, you as an astrophysicist and as a philosopher, what will you say? Will you say, I knew it, or will you be surprised?
Well, being a science journalist now, probably I won't have time to to react in that way anyway, because I will be extremely busy. But I will still be very surprised because, well, we know that the conditions for life are very good everywhere in the universe, but we still don't know how likely it is that life really gets out of these ingredients. And as astrophysicists, we usually imagine foreign life as microbes. So like, I don't know, bacteria or whatever. So nothing intelligent at all. And so for me, I would be extremely happy because then we could start all these interesting philosophical questions. How typical is our life? Well, now that I think about it, probably we would be disappointed very quickly, because then we would realize that we just have no connection at all, and that it would maybe be similar like our attempt to communicate with animals or with plants here on Earth, that there's not any connection at all. But well, I would be extremely happy because it would be so interesting to see whether there are some common properties that we have, or whether it's foreign in a way that we never imagined before. So, well, when this happens, of course, we should have another evening, another discussion, and then there are lots of other interesting questions that need philosophical input, for certain.
Grazie Sibylle, allora staremo a vedere. Signori,
So thank you, Sibylle. We will see. So now, ladies and gentlemen, we'll come to the end of this meeting.
io delle
I would like to recall the Terrace of the Stars on Monte Bondone. You find all the information on the Musée website. And let me thank those who made it possible. The Maffei service, the technician staff, and then the precious contribution of Mrs. De Poli and Mrs. Claudia Marsilli. This event will continue to be available in our channels in Facebook and YouTube. And then many thanks to all those who worked, Massimiliano Tardio, Stefania Taltel, and Christian Lavar. Special thanks to you all for being present, and to our guests, Sibylle Anderl and Mr. Costa. Thank you.